In Lesson 3, we want to learn about the mole concept in chemistry. Moles in chemistry are a little bit different than the little furry animals that are out in your garden. In chemistry, when I talk about moles, I'm talking about a group of atoms. Atoms are too small to count individually, but if I put a whole bunch of atoms together, and if it was a large enough group, I would be able to see them with my naked eye. I would be able to count them as a group. I would be able to put them on a balance and find the mass of them. So grouping atoms together is very helpful to a chemist. The group of atoms is called a mole. The analogy that people usually use is a mole is kind of like a dozen. You know, there's certain words that when you say that word, it makes your mind think of a number. So if I tell you I have a dozen eggs, you know that I mean 12. If I tell you I have a pair of shoes, you know that I mean 2. If I say that I bought a case of soda at the store, you know that I bought 12 cans were in a case. All of those words make you think of a number. Well, the word mole should make you think of Avogadro's number. And this is a number that you need to memorize and put in your brain for the test. Avogadro's number, named for Amedeo Avogadro, he was an Italian scientist. 1 mole is equal to 6.022 times 10 to the 23rd particles. So 1 mole is equal to that very large number of things. Now, some books use 6.022 times 10 to the 23rd. Some books round it off and they say 6.02 times 10 to the 23rd. We don't care which number you use, you will still get something close, okay? Now, when I say particles, different questions will word this different ways. Particles in chemistry can be atoms, ions, molecules, or formula units. So if you see any of those 4 words, there should be a little bell that goes off in your brain, and you should think of using Avogadro's number. A mole, it's a really big number. 6.02 times 10 to the 23rd, that's a lot of zeros. So if we write out all those zeros, look how large that is. To put it in perspective, if I had a computer that could count 10 million atoms a second, it would still take that computer 2 billion years to count up to a mole. It's a very, very large number, but that's because atoms are very, very small. I have to put a whole bunch of them together for it to be a large enough group. Now, here's an example of a problem that you could solve using moles. How many moles of lithium are there in 1.204 times 10 to the 24 lithium atoms? So you see the word atoms, that should be your clue that you might want to use Avogadro's number to solve this problem. So you start with the number and the unit that are part of the question. So 1.204 times 10 to the 24th atoms. And if I started with atoms, in my next conversion, atoms is going to need to go on the bottom. Remember the conversion factor stuff we learned in Lesson 3. The unit you started with is going to go on the bottom in the next step. So I'm changing it to moles, so my unit moles goes on top. It's helpful to remember that wherever you put moles at, either top or bottom, there's always going to be a 1 in front of moles. So I'm putting the 1 there, and I'm taking Avogadro's number and putting it on the bottom. To solve, you multiply across the top, you divide by what's on the bottom. 1.204 times 10 to the 24th divided by 6.022 times 10 to the 23rd, I get about 1.99 moles. I don't want you guys to get hung up on the rounding with this. You don't need to worry about Sig Figs for these answers. We just want to be sure that you understand the concept, okay? So if you told me the answer was 2 instead of 1.99, it's okay. As long as you're in the ballpark, we're happy. Here's another example. Again, I want to read the question and I want to pull out the number and the unit that are part of the question. So that's my starting point. 32.6 moles of strontium is my starting point. Okay, if I had moles to start with, moles needs to go on the bottom in the next step. I want to change it to atoms on top. The 1 goes wherever moles is, so the 1 goes on the bottom. Avogadro's number goes on top. So now I multiply across the top. My final answer is 1.96 times 10 to the 25th. There's also a way to relate mass and moles, to convert between those 2 units. And to do that, you're going to need a periodic table, and you are going to use the molar mass, or the gram molecular mass, off of the periodic table. The units for molar mass are grams divided by moles, and what you do, you look at the periodic table, and you take into account the number of atoms of each element that's in the compound. So if we pull out a periodic table, we would try to find helium. Helium is in the top right corner of the periodic table. It's atomic number 2, and its symbol is He. If I look at my periodic table, and I look at the very small number that's written below the symbol, below He, it has 4.0026. That is the molar mass of helium. The next one, N2, nitrogen. Nitrogen is one of the diatomic gases. Diatomic means they come in pairs. So this little 2 in the subscript is telling me that there were 2 atoms of nitrogen. So I would find nitrogen on my periodic table. It's number 7. Its abbreviation is a capital N. And I would do 2 times the mass of nitrogen. So 2 times 14.007. 2 nitrogens together then would weigh 28.014 grams per mole. Last example would be carbon dioxide. Its formula is CO2. Now, in this particular formula, I know that there's not a 1 written right here in the subscript, but they usually omit that 1. In CO2, there is 1 carbon atom and there are 2 oxygen atoms. So if I go to the periodic table, I add up the mass of 1 carbon plus the mass of 2 oxygens, and I would get around 44.009 grams per mole. The one thing to remember about the periodic table, different periodic tables that you use will have slightly different masses. Some periodic tables only give you the molar mass to 2 decimal places. The periodic table that I gave you does it out to 3 decimal places. You're still going to get an answer that is very, very close, so please don't get hung up on that. Okay, as long as you got a molar mass that is close to what we're looking for, you should be happy and good. Here's an example of how we can incorporate the molar mass into a problem. Remember that molar mass lets us change between moles and grams. So let's say that we had this problem. I would read it and I would pull out the number and the unit that are part of the question. So I'm starting with 388.2 grams. If I started with grams, grams goes on the bottom in the next step. I want to change it into moles, so the unit moles goes on top. I'm putting a 1 wherever moles is, so I'm putting a 1 on top. Iron is Fe on the periodic table. It's kind of in the middle. It's number 26. And below Fe, if I look on the periodic table, it's about 55.85. Okay, something close to that for the mass. So I'm putting that mass on the bottom. So 388.2, and then divide by the 55.85 on the bottom. My final answer, about 6.951 moles of Fe. Here's another one. We're going to use carbon dioxide this time. 66.0 grams of that carbon dioxide, that's our starting point. I started with grams, so grams needs to go on the bottom in my next step. I'm changing it to moles, so moles would go on the top. The 1 goes wherever moles is, so I'm putting a 1 on top. The grams is going to come from my periodic table. I have to add up the mass of 1 carbon plus the mass of 2 oxygens. And now I multiply across the top, divide by what's on the bottom. 66 divided by 44.01, I get about 1.5 moles of CO2 is my final answer. Now, we can string together some conversion factors, and that's what we're going to do here. There's no way to go directly between grams and particles, so that doesn't work. But we did learn that we could change grams into moles, and then we could change moles into particles. So to start with, we're going to take the number and the unit that's part of the question, 2.00 grams. I can change between grams and moles by using my periodic table. Grams was on top to begin with, so grams goes on the bottom in my conversion, moles goes on top. The 1 goes wherever moles is. I find boron on my periodic table. It weighs about 10.81. So grams on top, grams on bottom, that unit cancels out. The next thing I do, I have moles. I want to put moles on the bottom in my next step. I want to change it to atoms. I can change between moles and atoms using Avogadro's number. So the 1 goes where moles is, Avogadro's number goes on top. Multiply across the top, divide by what's on the bottom. My final answer, 1.11 times 10 to the 23rd atoms. This is example 6. So this one, we want to find mass, which is basically telling me that I need to find grams, right? Because grams was my unit for mass. I have 1.00 times 10 to the 22 formula units of MgSO4. That's my starting point. If I'm starting with formula units, then formula units goes on the bottom in my conversion factor. I'm going to change it to moles, because there's no way to go directly from particles to grams. We have to go through the mole. So the 1 goes where the moles are, so that's on top. Avogadro's number goes on the bottom where formula units are. The unit formula units cancels out. Now I'm left with moles of MgSO4, so moles will go on the bottom in my next step, and grams will go on top. The 1 goes wherever moles is, and this number 120.37, that number I got off the periodic table. I added up the mass of 1 Mg plus the mass of 1 S plus the mass of 4 oxygens. You multiply the numbers across the top, divide by what's on the bottom, you should get about 2 as your final answer. I made this island diagram to try to help you. People have told me before in the past that this was good for them. Sort of a visual representation of what we just learned. So if you start with grams and they ask you to find particles, either atoms, ions, formula units, or molecules, any particle, there's no direct way to go from grams to particles. That doesn't work. You have to go from grams to moles, and you would do that conversion using your periodic table to find the molar mass. So grams to moles, make that conversion, and then you can go from moles to particles using Avogadro's number. Also works in reverse. If you started with particles, you can change it to moles and then change moles to grams.